everyone, welcome to the study of complex mathematics. In this video tutorial, we are looking at pose and we are looking at the residue of the pose. So this question, you are going to find the residues of f of z, which is equal to z plus 1 multiplied by z minus 1 divided by z squared plus 1. Now, we are going to get the residue at all the pose. So we begin this one. This equation can be written as z squared minus 1 divided by z squared plus 1. When you multiply the numerator, when you expand the numerator, you are going to obtain that. Now, there are poles here. The poles are as follows. You have one of the poles is z1 is equal to I, and the other pole is z2 is equal to negative I. So there are two poles, and all of them are a simple poles. So we begin with the first one. For z1 is equal to negative I, we want to obtain the residue, which we represent as ri. It will be given by limit as z1 tend to I of z minus I multiplied by z squared minus 1 divided by z squared plus 1. Now, the denominator can be expanded so that we obtain the following. So we have limit as z1 tend to I of z minus I multiplied by z squared minus 1 divided by z minus I multiplied by z plus I. After expanding so you can see this part here will cancel out, so that now we are left with residue of I, which is given by limit as z1 tend to I of z squared minus 1 divided by z plus I. So that is what we obtain. We substitute now. When we substitute in the numerator, we are going to have I squared minus 1. I squared minus 1 divided by I plus I plus I, which is equal to negative 1 minus 1 divided by 2I, which is equal to negative 2 over 2I. So residue of I1 is equal to negative 1 over I. Negative 1 over I, which can be simplified as follows. You can multiply the denominator by I here. So you can multiply by I and you divide by I, so that you get negative I over negative part. You go to the second part. R negative I is equal to limit as z tend to negative I of z plus I multiplied by z squared minus 1 divided by z squared plus 1, which can be written as z plus I multiplied by z squared that divided by z plus I z minus I, which will reduce to ri is negative I is equal to limit as z tends to negative I of z squared minus 1 divided by, this is I, z minus I, which is equal to I squared, there is a negative outside, minus 1 divided by, you divide by minus I minus I. So this is equal to negative 2 over negative 2I, which is equal to negative I, which is equal to negative I, and that is the result that we obtain there. So thanks so much for taking your time to study with me on complex numbers. For more such learning, kindly tune on to my channel so that we may keep on learning together. Bye bye. See you in the next presentation as we keep on learning on how to identify the residues of a complex number. So today we have considered single residue, and we were given f of z is equal to z plus 1, z minus 1 divided by z squared plus 1. And you are going to identify all the residue at all the poles. Remember, the residue is given by r. It is given at where the function is not defined, and it is given by limit at z tend to alpha of z minus alpha, then you multiply by the given function, and you simplify using L'Hopital's rules and the other methods of simplification. So in our case, we end one of the poles at z is equal to I, and we have seen r at I is given by limit as z tends to I of z minus I multiplied by z squared minus 1 divided by z minus I z plus I, whereby we have reduced it to limit as z tends to I of z squared minus 1 divided by z plus I, whereby we have obtained here negative 2 divided by 2I divided by 2I, and we have simplified it as negative 1 over I, which you have seen it can reduce to I. It can reduce to I. So thanks so much for taking your time to study with us. For more such learning, kindly tune on to my YouTube channel so that we may keep on learning together. And for now, bye bye. See you in the next presentation.